This is part 2 of our What Are Functions, section 3.1 in the Big Ideas book. Yesterday we talked about what is a function based on the table or on the map. Today we're going to look at the graphs and we're going to look at some word problems. All right, so another way for us to tell if it's a function or not is to look at the graph. And the rule for a function, if it can pass the vertical line test, then it is a function. In order to pass the vertical line test, the vertical line has to be able to pass through the graph without touching the vertical line 2 times at the same moment in time. So for instance, as I run this vertical line through this graph, it never crosses the red line at 2 times in the same moment. It never crosses at 2 times at the same moment. So because it doesn't cross at 2 times in the same moment, it is a function. Okay, let's look at the next one. I'm going to run my vertical line test. Does it pass through the red line at 2 times at the same moment? It doesn't, so we're going to call it a function. I'm not sure what happened to my... what happened to my line there. There it is. All right, let's look at the next graph. As I run my vertical line test, what you'll notice is that my vertical line actually crosses at infinite points. So in this case, it does not pass the vertical line test. All vertical lines do not pass the vertical line test. Now let's make a table of that data. Now let's pretend this is 1, this is 2, this is 1, this is 2. So if I take that point, that is 2 across and 0. This is 2 across and 1. This is 2 across and 2. We can see that our x's actually repeat when we have a vertical line. So all vertical lines are not a function. All right, let's look at the next one. This is a parabola. Now, in a parabola, there is a slight angle. There's a slight angle, and even though it looks like it's a vertical line, it's not. When I run my vertical line test, you'll see that it does not cross the vertical line. And so now what we have is, all right, so now, as you see, I'm not sure if you saw that. When we run our vertical line, it never quite touches 2 parts at the same moment in time. So we would say that this parabola is a function. Now, here's where we really see it. As we run our vertical line, we notice that at 2 places in the same moment in time. So this is not a function. The vertical parts really are at a slant. So again, it is because when we pass our vertical line, I'm not sure where my vertical line went, but it never crosses at 2 points in the same moment in time. Here, it will not pass, so it's not a function. And the last one, no matter where it's at, it's crossing at 2 points in the same moment in time. So it's not a function. So we now know what it looks like in the map, in the graph, and also in the table. So number 1, I want you to pause the recording and tell me if these are a function. Number 1. All right, let's check our work. Number 1. Since it's 3, 7, 4, 7, 5, 8, and 6, 8, this is a function. Number 2 passes the vertical line test because there's no actual vertical line, so it is a function. Number 3, when you take a vertical line, it does not pass as it crosses the same spot at the same time in 3 different places. So this is not a function. Also, number 4, what this map really means is this: 5, -1, 5, -2, 6, -3, and 7, -4. And as you can see, the 5s repeat. So whenever we have a number with 2 lines coming out of the same input, then that is not a function. Not a function, because our x's repeat. All right, we're almost at, there's a little bit more. We're just kind of taking this to the next level. So when they ask us to state the domain and range for each function, when you look at graph number 1, we actually have to make a table and list our x and y's. So on the first point, where we have right here, that is -2, +2. On the second point, I have -1, -1, 2, 3. The third point, I have 2, +2. And the fourth point, I have 1, 2, 3, 4, +2. Do any of my x's repeat? No. So this is a function, but they're not asking us that. They're asking us to state the domain and range. Here, my domain is -2, -1, 2, and 4. And my range, remember, I don't need to list the repeats, so it's -3 and 2. Okay. Number 2 gets a little bit tricky. Now, when we talk about domain, we're talking about our x. So it's really how wide. When we talk about range, we're talking about our y, how high. So really, what we want to know with our domain here is how wide will I eventually use all these x's? If this keeps going on and on and on up in this direction, we are eventually going to use all these x's over here, and the same thing on this side. So what we would say is x is an element of the reals, or we could say x is any real number. Okay? Because I'll eventually use all the x values to continue this parabola. My range, however, my range will be much different. My range, the range, when we're asking about the range, we're asking how high. Now notice, I'm going to erase this. Notice that when we look at the parabola, it goes on and on forever, height-wise. The height goes on and on forever. So since we're talking about height, right, it's going to go on and on forever in that direction. But in the bottom direction, it's not. So we would say it has like kind of a boundary there. So we're going to say our range, our y, since our range is talking about our y's, values, our y is always greater than, here's 0, here's -1, here's -2, -3. Y is greater than -3. So when we are doing this, we're going to say that our range, y, is greater than -3. So that's when we're really looking at our graph. How high, how wide can this graph go? Number 3, the domain, remember, that's our width. That's our x-axis, so we're really talking about width. Now you have boundaries on your x-axis. Okay? That's one boundary. Here's another. So what we would say is x is less than, the highest x value is 1, 2, less than or equal to 2. And notice it means equal to because that point is filled in. So it includes that point. And the minimum value is less than or equal to -2. That's what we call an in-between statement. It's showing the boundaries of the width. Now the range, that's how high it goes, okay? How high it goes, I'm looking at the lowest point for my y's and the highest point. Okay, and I've got y, I'm going to do another in between. And what is the lower boundary? See if you can figure this one on your own. And what is the upper boundary? My lower boundary, this is -1. That's what I'm really kind of talking about right here. And my upper boundary, it goes to here, which is +1, 2, 3. Is that making sense? We're looking at width and height. Domain is our width. Range is our height. It's our y-axis. All right, the next one. Again, pause the recording, and I want you to try this one on your own. Think of width versus height. All right, now let's check our work. Now, really quickly, my domain, I'm looking at my width. It goes on in this whole direction. So, my x is greater than or equal to -2. Where my range, it's going to keep getting higher and higher because it's at an angle and there's an arrow here on the end. So eventually, but my range, this is the lowest it'll be. So y is greater than or equal to 0. Okay? Y is greater than or equal to 0. And you should put those in braces. All right, so now the last part of our lesson, which are, they give us an equation and they created a dependent relationship. It represents the amount of Y in fluid ounces of juice remaining in a bottle after X gulps. So X is gulps, Y is the juice in the bottle. Identify the independent and the dependent variables. So what in this situation depends on the other? Because my depender is always my Y. So if Y represents the juice in the bottle, that is your depender. Depends on how many gulps I take. X is my independent. Okay? Whoops. So Y is we'll say X, which is gulps, is the independent. And Y is the juice left. And that is our depender. Okay? Now, what they want us to do is they're giving us input values. That means we substitute that into the equation. So, -3x plus 12 is y. So when x is 0, we have to use all of them. -3, 0 gulps, there will be 12 ounces. When there's 1 gulp, there'll be 9 ounces. When there's 2 gulps, there will be 6 ounces. When there's 3 gulps, when do I get to stop? There will be there will be 3 ounces. And when there's 4 gulps, -3 times 4, there will be 0 ounces. So when do I get to, I have to try all of these domains. I have to input them. Okay? And so it says when the domain is this, what is the range? The range would be 12, 9, 6, 3, and 0. And you have to put it in the same order. All right? Pause the recording if you need to take these notes. I would say the range is... All right, let's try the next one. Why don't you pause it, and I want you to tell me the independent and dependent variables, and then I want you to state the domain, state the range for the given domain. Pause the recording. All right, let's check our work. A represents the number of A avocados you have left after making B batches of guacamole. So, what is our depender here? Is our leftovers depend on the amount of batches we make. So A is our dependent. And B is our, B stands for batches, that is our independent. Okay, now they want us to use the domain. Okay, here's my x, and I'm going to start with 0. So I'm using the equation, negative 4b plus 14. So I guess this would be my b. And that would be my a. And so negative 4 times 0, that would be 14. Then I'm doing 1, negative 4 times 1 plus 14, it's going to be 10. 2, negative 4 times 2 plus 14, that's negative 8 plus 14 is 6. And then I'm going to do 3, negative 4 times 3 is negative 12 plus 14 equals 2. So I've got, the question is, what is the range? The range is 14, 10, 6, and 2 for these domain. All right? So that's basically our lesson that will finish it up. I'm going to give you one more to try. These are just the examples in the book. Okay, let's see what they've done. Let's see, 12. The function represents the temperature T of an oven after preheating for m minutes. So my depender is the temperature, depends on how long the oven's been on. The independent. M is my minutes is independent, and T is temp, sorry, and that's dependent. Okay, now it says a recipe calls for an oven temperature of 350. Describe the domain of the function. This time, what are they giving us? If they give us the temperature, they're giving us the range, and we have to figure out the domain, the M. So we have to substitute in. We're substituting in for that T. I'm subtracting 65. We have 5, and that becomes 4. That becomes 2. So 14 minus 6 is 8. And I get 285 equals 19M. I'm dividing both sides by 19. And we get M equals 15. Makes sense of that domain. So that M stands for minutes. So it says describe the domain and range of the function. So at 15 minutes, the domain, the temperature will be 350 degrees Fahrenheit, the range. Got it? All right, and I think that's it. Jeez, it's been a lot. Yep, that's the end.